Imagine you are writing a letter to someone who just lost their closest friend. You search for something true to say, something that will not sound hollow, and every sentence you draft ends up sounding like it belongs on a sympathy card you have read 100 times before. Now imagine you happen to understand the deepest laws of the universe better than almost anyone alive, and when you finally sit down to write that letter, this is the line you land on instead. The distinction between past, present, and future is only a stubbornly persistent illusion. That is not a monk. That is not a poet. That is Albert Einstein, writing to the family of Michel Besso in March of 1955, days before his own death, after losing the closest friend he had known since the two of them were students together at the Zurich Polytechnic decades earlier. He was not reaching for comfort. He was reporting, as plainly as he knew how, what his own equations told him about a friend who had just died. Here is the part most people skip past when they hear that line quoted. Einstein was not being poetic. He meant it as physics. And if he was right, "they are gone" might be one of the most scientifically inaccurate sentences a grieving person can say. This is not a metaphor somebody borrowed for a eulogy. It is the same physics sitting underneath the GPS app in your pocket right now, quietly correcting itself by roughly 38 microseconds a day because the satellites overhead experience time differently than you do down here on the ground. If relativity did not actually describe reality, your phone would drift kilometers off course within about a week. So the real question is not whether Einstein was trying to be kind to a grieving family. It is whether he was being accurate. And if he was, exactly how far that accuracy reaches. Because the honest answer is stranger and more limited than most people assume. So does that mean death is not really the end? Or is that the exact spot where a dozen of the internet's biggest science channels quietly stop doing physics and start doing wishful thinking? If you are the kind of person who wants to know precisely where real evidence runs out before anyone starts filling the rest in with hope, you are going to want to stay for this one. And it would genuinely help this channel if you subscribed before the next stop. Because that is exactly the kind of line we spend every week trying to find here. To understand what Einstein actually proved, you have to start with a question that sounds too simple to matter. What does now really mean? Picture two bolts of lightning striking a stretch of railway track at the exact same instant, one near the front of a moving train, one near the back. A person standing on the platform, watching from outside, sees both flashes at once. But a person sitting inside the train, moving toward one flash and away from the other, sees them land at slightly different times. Neither of them is wrong. Neither clock is broken. This is the thought experiment Einstein built his 1905 paper around, titled On the Electrodynamics of Moving Bodies. And it is where the real trouble started, because it means there is no single universal now that everyone in the universe shares. What counts as simultaneous depends entirely on how fast you are moving relative to what you are watching. That one idea forced a mathematician named Hermann Minkowski, who had actually taught Einstein at the Zurich Polytechnic and once reportedly dismissed him as an indifferent student, to redraw the picture of reality completely. In a lecture titled Space and Time, delivered at the University of Göttingen in 1908, Minkowski proposed that space and time were never two separate things to begin with, but one single four-dimensional structure, later nicknamed the block universe. In that structure, every event that has ever happened, past, present, and future, occupies a fixed coordinate that never gets erased. Nothing happens and then disappears. It simply exists at its coordinate, permanently, the way a city still exists on a map, whether or not you happen to be standing in it right now. That is an elegant idea. It is also, on its own, just an idea, until somebody actually tests it against reality. In 1971, a physicist named Joseph Haffel and an astronomer named Richard Keating did something almost absurdly simple for a test this consequential. They put 4 cesium atomic clocks, accurate enough to lose less than a second every few thousand years, onto ordinary commercial airliners. They flew the clocks once around the entire planet heading east, and once around heading west, then compared them against identical stationary clocks sitting at the United States Naval Observatory. The traveling clocks came home measurably out of sync, off by mere billionths of a second, but off in precisely the pattern relativity predicted, down to the direction of travel. Their results were published in the journal Science in 1972. They were not describing a philosophy. They were holding a physical object, an actual clock, that had proven time itself does not run at the same rate for everyone. The Haffel-Keating flight was not an isolated stunt either. Decades earlier, in 1941, physicists Bruno Rossi and David Hall measured something stranger falling out of the sky. Tiny, unstable particles called muons, created when cosmic rays slam into the upper atmosphere. A muon decays so quickly that, by ordinary arithmetic, almost none of them should survive the trip down to sea level. And yet, detectors kept finding far more of them at the bottom of a mountain than the particle's own lifespan should allow. The muons were not breaking the rules. Moving at close to the speed of light, their internal clocks were running slow relative to ours, exactly as relativity predicted, giving them just enough extra time from our point of view to complete the fall. Two completely different experiments, 4 decades apart, one using laboratory particles and one using commercial airplanes, landed on the same answer. You do not have to take a decades-old experiment's word for it either, because you are almost certainly carrying a working demonstration of the same physics in your pocket this very second. Every GPS satellite orbiting the Earth runs on an atomic clock pulled in 2 directions at once by relativity. Its speed slows the clock down by about 7 microseconds a day, while the weaker gravity at its altitude speeds the same clock up by about 45 microseconds a day. Add those 2 effects together, and the net drift comes out to roughly 38 microseconds a day, which sounds tiny until you remember that GPS timing needs to be accurate to billionths of a second to pinpoint your location. Every one of those satellites has its clock corrected using Einstein's equations before the signal ever reaches your phone. Switch that correction off, and GPS would drift roughly 10 kilometers off target within a single day. It works because relativity is not a metaphor. It is engineering, running silently over your head right now. So here is where the tested, verified physics actually lands. Time is not universal. Simultaneity depends on your motion. And the block universe model built on top of those facts says nothing in spacetime is ever erased, only located somewhere you personally can no longer reach. That much is physics, not comfort. Now for the part where most of the videos ranking for this exact topic tend to go quiet. If nothing in spacetime is ever erased, why does it feel like time is moving, like the past really is gone? The answer is entropy, a concept formalized by the physicist Rudolf Clausius in 1850, and given its statistical foundation by Ludwig Boltzmann in the 1870s. Entropy describes disorder, and the universe is reliably, relentlessly sliding toward more of it. An egg cracks and scrambles easily. It never unscrambles itself back into a shell on its own. That one-directional slide toward disorder is what creates your felt sense of time flowing forward, even though the block universe underneath treats every moment as equally, permanently real. Physicists call this the arrow of time, and it is a genuinely separate phenomenon from the block universe itself. One explains the geometry. The other explains why you experience that fixed geometry as something that flows. And here is the line almost nobody draws clearly enough. The mathematics of the block universe is settled, tested physics. What it means for a person, for consciousness, for whether someone you loved is still there in any sense you could recognize or reach, is not physics anymore. That part is philosophy wearing a physics costume. Physicists, including Sean Carroll and Sabine Hossenfelder, some of the very researchers whose work gets borrowed to make comforting claims about death online, are careful to say exactly this in their own writing. Space-time preserves coordinates, not people. The equations promise you nothing about experience. Some corners of the internet try to patch that gap with quantum mechanics instead. The idea that consciousness might somehow persist because of quantum effects happening inside the brain. It is worth testing that claim honestly rather than waving it away. In 1998, the physicist Max Tegmark, then at the Massachusetts Institute of Technology, actually ran the numbers in a paper published in the journal Fortschritte der Physik. He calculated how long a quantum superposition could realistically survive inside the warm, wet, chaotic environment of a living neuron before collapsing into ordinary classical behavior. The answer came out somewhere between 10 trillion and 100 quintillion times faster than a neuron actually fires. In plain terms, whatever is happening in your brain when you think a thought, it is not quantum in any way that could plausibly carry your identity forward after death. That door, the one certain videos love to leave cracked open for dramatic effect, is about as firmly closed as physics gets. So the honest picture is narrower than the comforting one, and also stranger. Every coordinate your life has ever touched is, according to the best tested physics available, permanently real and unerasable, fixed inside a four-dimensional structure that atomic clocks and GPS satellites quietly confirm every day. What is not proven, what no equation anywhere claims, is that the person is still there to notice it. Try the arithmetic on your own life for a second. Somewhere out there in that block, at a fixed, permanent coordinate that physics says can never be deleted, there is a version of some ordinary afternoon you spent with someone you love, still happening, exactly as fully and permanently real as this exact second is right now. Not gone, not erased, just sitting at a coordinate you can no longer reach from wherever you happen to be standing today. That is either the strangest comfort modern physics has ever offered, or the most honest way science has ever found to describe grief without lying about it. Notice which one it is not. It is not a promise that anyone is watching or waiting or still capable of missing you back. Physics was never built to answer that part, and every video that quietly slides past that gap is doing storytelling, not science, however good the storytelling feels at 2 in the morning. Einstein himself seemed to sit inside that exact uncertainty, and he had far less time to sit with it than most of us get. He wrote his stubbornly persistent illusion line to comfort a grieving family, offering his own life's work as the only honest thing he had left to give them, at a point when he already knew, better than almost anyone in history, precisely how much of that comfort his own equations could and could not back up. A little over a month later, he died too, joining Besso at a coordinate of his own, one his physics says is no less real tonight than it was the day it happened. Physics will not tell you whether that is enough. It will only tell you, with more certainty than almost anything else humans have ever measured, that the moment itself is still there, fixed, unerasable, sitting exactly where it always was. What you do with that fact, whether you find it consoling or unbearable, or somewhere strange in between, is the part no equation has ever solved, and possibly the part no equation was ever meant to.